looks like it's working. Okay, so let's briefly recall a few things we did last time, and then prove the theorems which were stated. Okay, so well, first of all, let's recall the definition of of the subalert norm on complex functions, complex valued functions with compact support. So the definition is as follows. We need to integrate but yes, this is where I went wrong last time. So we need to multiply against 1 plus psi squared, modulus of psi squared, and to the power s, and not minus s. Okay, briefly, the idea is to or equivalent norm. Okay, let me use another color to emphasize that this norm is equivalent. It's not the same, but it's equivalent. So I will use the red color to denote. No, it's not working. The equivalent norm is obtained by taking the sum of the squares of the L2 norms of all derivatives of order up to and including s. sorry. Now I have to use to use an X. And this definition makes sense for L1 integrable functions, but not in general for L2 integrable functions. Okay, so far so good. We we can generalize this definition to functions with values in C something, not necessarily C, and also to sections of vector bundles using a partition of unity. Well, this part is straightforward, so I think there's no need to go through it again. If not, please let me know. And then we take the completion and call the result WS XE. And we stated two lemmas last time. And well, Sobolov's lemma says that if F belongs to WS, then basically the function F is in fact continuous and even belongs to some and even has some number of continuous derivatives. Okay, so let me state it like this. And let's also assume that no, what was it? No, this is wrong. That's, uh, okay. Well, in a moment we'll talk about this lemon in some more detail and prove a local version of it. But first, let's state another result. If T is greater than S, then the inclusion W T inside W S is compact. Are there any questions, remarks, etc.? Okay. The well, one possible question: what is N? We have we have an X which is smooth and compact, and let's say that N is the dimension of X. Okay, let's prove a local version of sublet lemma, which which then can be used to prove the full lemma, but we will not go through all the details of going from local to local. Well, suppose I have an L2 interval function on Rn, and sorry, it's supposed to be the S norm. Suppose the S norm of the function is finite. Then then f is essentially a ck class, a ck smooth function. Well, with the usual caveat, after modifying the function on a set of measure zero, the back measure zero. Okay, with the same inequality, s greater than 1/2 n plus k plus 1. Okay. Well, let's prove the local version. Well, I want to use the okay. So I know that the Fourier transform exists. It may or may not be given by the integral, but it does exist. So I just take the inverse Fourier transform and well, at the moment, I don't know whether or not the integral exists. So let's try to let's try to first remember the relation of this formula for the inverse Fourier transform and the actual function f. Now the relation is as follows: if the integral if the integral exists for all x, then this integral in fact coincides with the f, except on a set of measure zero. uh, and uh, well, uh, another uh, another statement which I want to use without proof that uh, um, uh, this this integral is if the integral if the integral for which calculates the alpha derivative of um, well of f tilde converges, then uh, for all x, then the the derivative the alpha derivative exists, and is continuous. Again, this is a black box. Oh, let's let's okay. Let's look at the let's look at the let's look at the let's look at the integral. So we have where we want to know whether or not the integral um, well, we can forget about this factor because we want to see whether or not the integral converges, and this factor doesn't really change anything. Okay, so let's get rid of this, and what do we get? We get okay. So we have 10 minutes left, and then we'll have to use the same link to again. Okay, but we'll hopefully finish the proof by then. Okay, so what do we have? We have f roof of psi psi to the alpha. Okay, then I divide and multiply by the factor. Well, let me put a 1/2 here, and then I use the same factor in the denominator. D psi. Okay, and then I use the well, let me okay, let me put a modular square. By the way, I may have forgotten it. Oh, no, no. Here I have. Okay. No, let me get rid of the square. Okay, now I'll keep the modulus. Now I want to use the Cauchy-Schwarz inequality. Now this integral is less than or equal of the S norm of f times the integral of psi to alpha one plus psi squared to the s. Okay, what does the and to the power 1/2? What does the Cauchy-Schwarz inequality say? Well, it says that the modulus of the scalar product AB is less than or equal of the norm of A times the norm of B if the norm is induced by some Euclidean scalar product, which is basically what we use here. But we apply this to to the scalar product on functions on Rn with weight 1. So we need to know whether or not this integral converges. Does the integral converge? What do you think? Yegor, how to find out? Okay.
Можете напомнить, альфа там у нас что?
Значит, альфа это да, значит, альфа это какой-то мультииндекс. Alpha is a multi is a multi-index. What does this mean? Well, this means we have a product of psi 1 to some power plus psi 2 to some power, times psi 2 to some power, and so on. And the sum of the powers is something we denote the modulus of I. So basically, we may as well write psi to alpha by 1 plus psi squared to the s. And by the way, I forgot the psi. Okay, now Yegor, how to find out whether or not this thing converges?
Ну, должен сходиться, конечно.
Ну, значит, а как понять? Ну, да, действительно, там все числа подобраны так, что он сходился. Значит, ну, как понять, сходится или не сходится?
Ну, так пока сходу не знаю.
Хорошо, а как, значит, чему равен декибриан перехода от полярных к Декарту? So let's pass to polar coordinates. Well, we'll get some constant. Let's forget about it. And then we'll get the integral from 0 to infinity, and then we'll get r to the power 2 modulus alpha.
Подождите, так там подинтегральное выражение только от модуля кси зависит, да?
Да.
Ну, то есть это от одной переменной интеграл фактически, но
Да,
там
это
еще
интеграл
двойной.
Да, совершенно верно. So we have this, and then dr, and then we have some extra factor because there is an r to the something in the Jacobian. In the determinant of the Jacobian matrix. А кто помнит, значит, в какой степени там стоит r?
В n-1, по идее.
Oh, okay. So r to the n minus 1. Okay, so we basically get the following equation: 2 modulus alpha plus n minus 1. Okay, I'll save the notes. Minus. And by the way, s minus 2s should be less than minus 1. There are no problems at 0 because of the 1. Okay, I'll save the notes, and I think this is it. We'll come back to this after we reconnect.